100,000 years ago, the Earth was crowded with giants. Giant mammals still dominated entire landscapes. In the forests of Asia, a giant ape searched for food in a world already beginning to vanish. Across colder regions, different kinds of humans struggled to survive on a planet growing increasingly unstable. At the time, nothing about the future seemed inevitable. Around 100,000 years ago, during a period of long-term environmental instability, the forests of Southeast Asia still supported one of the most extraordinary primates ever to exist. This is Gigantopithecus, the largest primate to have ever lived. We do not know its full appearance with certainty. The fossil record is fragmentary, mostly teeth and jaw bones, but even these remnants tell a consistent story. The teeth are enormous, thickly enameled, built for grinding tough plant material, like bamboo, fruits, fibrous vegetation. This was an animal shaped by a life in the forest. At full size, some estimates suggest individuals may have reached up to 10 feet when standing upright, though more conservative interpretations place them closer to 6.5 feet. Either way, this was a creature of immense strength. But it was not a predator. It did not dominate through aggression. Its survival depended on something far more fragile: stability. For millions of years, that stability held. The forests provided dense canopies, year-round vegetation, and predictable food sources. But now, something is shifting. The forest is no longer continuous. Patches begin to thin. Open spaces appear where dense growth once stood. The variety of plant life changes, and with it, the availability of food. Isotopic evidence preserved in the enamel of Gigantopithecus suggests a strong reliance on forest-based resources, even in regions where more open environments were available. This was not an animal that adapted easily to change. It stayed where it had always survived. But the forest is slowly retreating, and for a creature this large, this specialized, even a gradual loss becomes a critical problem. Across the grasslands of North America, herds of Columbian mammoth move steadily across the terrain. These animals are immense, some standing nearly 13 feet at the shoulder and weighing close to 22,000 pounds. Their long, ridged molars are adapted for grinding grasses and coarse vegetation, allowing them to exploit food sources spread across vast distances. They live in social groups, likely structured around experienced females, similar to modern elephants. In open environments, where cover is limited, cooperation becomes essential. Knowledge of water sources, migration routes, and seasonal change is shared across the herd. Size offers protection, deterring most predators. Their long, curved tusks, sometimes stretching up to 4 meters, served for both defense and foraging, from stripping bark to clearing vegetation. But it also comes with a cost. A body this large requires a constant, reliable supply of food. When conditions shift, even slightly, that balance becomes fragile. Far to the south, a different evolutionary story unfolds. In the long, isolated ecosystems of South America, Toxodon represents a lineage that developed in near isolation for millions of years. Roughly the size of a rhinoceros, with a heavy, barrel-shaped body and continuously growing teeth, it was adapted to processing tough vegetation. Its anatomy puzzled early scientists because it seems to resemble several modern animals at once, without fully matching any. The forward placement of its eyes, ears, and nostrils once suggested a semi-aquatic lifestyle, similar to hippos. However, isotope analysis of its bones and teeth shows it fed mainly on land plants, supporting a fully terrestrial life. In other regions, survival depends not on size or isolation, but on competition. In Eurasia, cave hyena occupy a demanding ecological role. Larger and more powerfully built than its modern relatives, it is both hunter and scavenger. Its diet was broad, ranging from horses and deer to much larger prey when the opportunity arose. Fossil evidence shows that it transported carcasses into caves, consuming them in relative safety. Some cave sites also reveal repeated use over generations, suggesting that these locations functioned as long-term dens where food was stored and consumed. But it does not hunt alone in this landscape. Wolves, big cats, and even human groups compete for the same resources. Every carcass, every successful hunt becomes part of a wider struggle. In Australia, that struggle takes a different form. Quincana is unlike any crocodile alive today. Adapted for life on land, it possesses longer limbs and teeth that are laterally compressed and serrated, features suited for slicing rather than gripping. This xiphodont dentition is more commonly associated with terrestrial predators, allowing it to cut through flesh rather than simply hold prey. It occupies the role of a terrestrial predator, capable of short bursts of speed, preying on animals away from water. Its limb structure indicates a more upright posture compared to modern crocodilians, with reduced reliance on sprawling movement, making it better suited for locomotion on land. In this environment, Quincana was likely a dominant predator, hunting medium to large land animals and possibly even early human populations in Australia. And in parts of Africa and Eurasia, another unusual herbivore emerges. Civatherium, a massive relative of modern giraffes, combines a powerful build with a moderate neck length and distinctive, antler-like structures. Rather than reaching extreme heights, it feeds within a different vertical range, exploiting resources unavailable to smaller animals. Body mass estimates suggest that some species, such as Civatherium giganteum, may have weighed over 1 metric ton, making it one of the heaviest members of the giraffe family. Each of these species reflects a different strategy: mobility, isolation, competition, specialization. Life is not lacking in diversity. It is abundant, adaptive, and constantly adjusting. but it is not stable. To understand what is happening to these ecosystems, we need to step back, away from individual species, and look at the planet itself. Around 100,000 years ago, Earth was deep within the last glacial period, part of the ongoing Quaternary Ice Age. This was a slow, long-term climate phase where ice sheets advanced and retreated over tens of thousands of years, rather than a sudden freeze. At this time, the global climate was shifting toward colder conditions, with temperatures slowly dropping and vast ice sheets expanding across North America and Eurasia. These ice sheets stored vast amounts of water, causing global sea levels to fall and subtly reshaping coastlines and continental connections. But this was not yet the extreme. The ice had not reached its maximum extent. That would come much later. This is a world in transition, cooling, shifting, but not yet at its harshest. And it is this transition that changes everything. As temperatures fall and atmospheric patterns shift, rainfall becomes less reliable. Many regions grow drier. Dense forests begin to break apart, giving way to more open landscapes, grasslands, savannas, and mixed environments. That's why forest-dependent species decline, while open terrain species expand. The shift isn't just about colder temperatures, it's about ecosystems being rearranged. What makes this process so powerful is its pace. It unfolds slowly, often across many generations, almost invisible within a single lifetime. But it is directional, because once climate systems shift on a global scale, they do not easily return to what they were before. As the climate continues to cool, the changes are no longer limited to temperature or vegetation. The very shape of the planet begins to shift. During the last glacial period, vast quantities of water became locked in continental ice sheets. As glaciers expand across North America and Eurasia, global sea levels fall, sometimes by over 330 feet. Coastlines retreat, and areas once submerged beneath shallow seas are gradually exposed. New land appears where there was once only water. One of the most significant examples is the Bering Land Bridge, a broad stretch of land connecting Asia and North America. It does not emerge all at once, but slowly, as falling sea levels reveal a corridor between continents. This changes how life moves. Animals that were once separated by oceans can now migrate. Herds expand into new territories, following familiar resources into unfamiliar lands. Predators follow behind them, and over time, ecosystems that evolved in isolation begin to connect. These are not sudden invasions, but gradual expansions, unfolding over generations. At the same time, many regions become fragmented. Changing coastlines and environments isolate populations, disrupt migration, and shrink habitats. What emerges is a dynamic geography, one that is constantly reshaping the boundaries of life. Because geography is not just a map, it is a system of access and limitation. In a world-changing shape, those boundaries quietly decide which species survive and where their story ends. As environments shift and species respond, one group stands apart, not because it is unique, but because it is many. Around 100,000 years ago, the Earth was home to multiple kinds of humans. Homo sapiens existed alongside Neanderthals, Homo erectus, Denisovans, and Homo floresiensis. These were not isolated curiosities. They were established populations, each with its own history, its own adaptations, and its own place within the ecosystems of the time. They lived in different regions, but their ranges were not always separate. Some occupied the colder environments of Eurasia. Others remained in tropical or subtropical zones, and some were confined to islands. The concept of human was not yet singular. It was a category defined by diversity, a collection of closely related but distinct species sharing the planet at the same time. And each of them survived in a different way. In Eurasia, Neanderthals were highly adapted to cold, fluctuating climates. Their bodies were compact and muscular, with shorter limbs that reduced heat loss. Archaeological evidence shows that they controlled fire, created tools suited for close-range hunting, and targeted large animals such as bison and deer. Their strategy was one of specialization, deep knowledge of a particular environment, refined over thousands of years. Homo sapiens, by contrast, appear to have followed a more flexible path. Rather than focusing on a narrow ecological niche, they occupied a wide range of environments, from African grasslands to coastal regions, and, eventually, colder climates. Evidence from sites such as Blombos Cave shows the use of pigments, engraved patterns, and complex toolkits. These behaviors suggest not only practical adaptation, but also symbolic expression, communication, identity, and shared meaning within groups. This difference matters, not because one approach is inherently superior, but because they represent different adaptive strategies. One emphasizes efficiency within a stable context. The other emphasizes flexibility in a changing one. But these species did not evolve in isolation from one another. As climates changed and landscapes opened, their territories began to overlap. Encounters became inevitable. In parts of Eurasia, Homo sapiens and Neanderthals lived within the same regions, sometimes at different times, sometimes possibly at the same time. Genetic evidence now shows that they did more than coexist. They interbred. Today, many human populations outside Africa carry small but measurable amounts of Neanderthal DNA, a direct biological record of these encounters. A similar pattern is seen with Denisovans. Though known primarily from fragmentary remains, their genetic legacy persists in modern populations across parts of Asia and Oceania. This suggests repeated contact, interaction, and gene flow between groups that were once thought to be entirely separate. Even more isolated species, such as Homo floresiensis, reflect how geography could shape human evolution in unique directions, producing forms adapted to highly specific conditions. These interactions were not simple. They involved competition for resources, overlapping territories, and changing environments. Some populations declined, others adapted, some merged. What emerges is not a linear progression from one species to another. It is a network. A complex web of populations that met, separated, and reconnected over time. A system shaped not by a single path, but by many intersecting ones. The story does not end here. The world is still in motion. Within the last glacial period, climate does not follow a simple, steady decline. Instead, it fluctuates, shifting between colder and slightly warmer intervals, altering rainfall, vegetation, and the distribution of life. Ice sheets continue to expand, but not uniformly. Regional environments respond in different ways, creating an increasingly complex and unstable global system. For the species living within it, these changes are real. Habitats shrink or break apart. Food becomes less predictable. Migration routes shift or disappear. For large animals with high energy demands, even small environmental changes can have significant consequences. For specialized species, the margin for adaptation becomes increasingly narrow. This is the point where pressure begins to accumulate, not all at once, but steadily. Some populations begin to decline, others become isolated as their ranges shrink. Survival is no longer about size or strength, but adaptation to instability. At this moment in time, nothing is certain. No species knows whether it will endure. No ecosystem is fixed in its final form. Climate continues to shift, landscapes continue to change, and survival remains an ongoing process, not a guaranteed outcome. From a scientific perspective, the fossil record shows both persistence and decline, but not certainty. Around 100,000 years ago, many lineages still appeared stable. Their disappearance had not yet begun. "100,000 years ago, the future was still unwritten. Many species walked the earth, many ways of being human existed, and yet, only one would remain.